Hi, Sam Roberts here from Roberts Geospatial. We're looking at ProRaster Scientific today, and I just want to take you through a common workflow where you've downloaded a large raster from the internet. You've got it in a set of smaller raster tiles. You want to put those tiles back together into one raster, and then you want to clip out a portion of that raster to a polygon and export it to a TIFF file, which you can then take into some other application like QGIS, for example. So let's get straight into it. I have here GEBCO 2023, this global data set, and so we've got 8 TIFF files, which are the tiles. So what we do is we go into the resource editor, add a new raster source. I'm going to call this GEBCO 2023 tiles. Hit OK. Now I can just drag and drop these TIFF files into the raster source editor. I'm then going to hit the prepare button and it's going to work away now and produce the overview pyramids. So we're just going to wait for that to finish because I'm on a one-take system here. There's no video editing, so if you don't want to watch a progress bar, then skip forward 30 or seconds or so. So it's creating the overview files, and it's also computing statistics. This is something, certainly the overview files are something that we have to do in a raster system where you want quality rendering. So this is just a step that you have to go through once. Once you've done it, you won't ever have to do it again. Computing the statistics is not necessary, but it's a good idea. It's always a good idea to have a complete understanding of what your data is like. So we're just about done now. In File Explorer, you'll see that a whole bunch of other files have appeared in the directory where my original TIFF files were. So that's done. So now we have our raster source called GEBCO 2023 tiles. Hit OK, and that will save it. So it's rendered it straight away, and you can see the individual tiles in this rendering. So that's not what we want. Now we're going to put it together. So I'll go to the processing menu and select a join operation. Join operation takes a raster source. So it's going to take all those tiles, and then we'll output, we'll give it a file name for output, data demo clip. So we'll call this GEBCO joined. Oops, joined. Save. And hit OK. Now we've got one raster. We're working with virtual rasters here, so it hasn't actually done any processing, but it's brought it all together as a virtual raster. Now we want to clip out a polygon. So let's go back into the processing menu and go clip to polygon. So I'll load up the file that I just worked with. Let's go details. We called it GEBCO joined. Specify the output file name, so we'll call it GEBCO clipped, and we'll do New South Wales. Now I select a polygon that I want to clip it to, so I can browse to a map info table which contains my polygons, or you have a list of recents that you've accessed. So I'm going to go for New South Wales. Hit OK. So here's our clipped polygon, clipped to the state of New South Wales in Australia. Now I want to export this out as a TIFF file, which I'm going to take into some other software. So I go into processing, I hit export operation, load up GEBCO clip to New South Wales. It will export either to an MRR or to a GeoTIFF or band interleave, so simple sort of common formats. So we're going to use GeoTIFF, and this is kind of designed to export complicated rasters with lots of different fields and bands and and temporal dimensions things that you'll find in virtual rasters that you output from the multispectral processing. So what it does is it outputs every single band of the source raster to a different TIFF file, and it puts it into a folder structure and constructs a folder, makes a folder structure that reflects the fields, the bands, and the events in that source raster. We have a simple raster in this case, but I'm going to tell it what folder to put it in. I'm going to go into demo clip. I'll make a new folder. We'll call this, it was New South Wales, wasn't it? So we'll go into New South Wales. Select folder. Resolution level is 0. That's your base resolution level. Hit OK. So that's done that. So let's just get rid of all these now. Close these algorithms so we can see what we're dealing with. Come back to here, New South Wales. Here's our band TIFF file. View details. And so we'll just drag and drop that in. And there's our clipped raster. Just go in here and we'll turn everything to nearest interpolation, nearest neighbor, which will enable us to see the cells. Go to cell value tool. You can see here that the cell values have been unchanged. So we haven't changed any data. We've preserved the original raster perfectly through that whole processing chain. There hasn't been any interpolation or anything happen. And even though we haven't specified any information about the output raster, we haven't said what the cell size is, we haven't said what the alignment is, we haven't said what the coordinate system is, all that's come through the virtual raster processing chain. You don't have to set it, and at the end of the day you've got a perfect replication of what your original data was. So that's that. And of course, perhaps if we bring up QGIS, so now we have a TIFF file, and you might want to take that into there, and there it is, and it displays as it does. So that's how to follow that little processing step where you bring rasters together, bring tiles of a raster back together, clip out a certain portion of it, export it to a new file, take it into some other package, all using the virtual raster processing chain functionality that's in ProRaster Scientific. So thanks for watching.